everyone. My name is Sandra Kim, Professional Development and Strategic Programs Director for the Irrigation Association. Welcome to the IA Manufacturer Series webinar titled Reliable Irrigation Freeze Alerts at Your Fingertips, sponsored by Watts. Founded in 1874, Watts designs, manufactures, and sells an extensive line of flow control, water safety, water filtration and treatment, radiant heating, and drainage products for the commercial, residential, and institutional markets. Watts is committed to helping its customers optimize system performance, improve reliability, and conserve critical resources. Thank you, Watts, for making today's webinar possible. Before we get started, I would like everyone to know that this session is being recorded and that all attendee microphones will be muted. This particular webinar is worth 1 IA CEU. You may record the CEU in your profile on IA's website at irrigation.org. If you have any questions, please type them into the chat box. There will be a Q&A session at the end of the presentation. Our speaker today is Nadine Mirza, the Senior Product Manager at Watts. Nadine is a seasoned electrical engineer by trade with over 20 years of experience in developing Internet of Things solutions. Without further ado, I'd like to give our speaker the mic. Nadine.
Thank you, Sandra, and good afternoon, folks, or good morning, depending on where you are. Thank you for being able to join us, and we look forward to talking to you and sharing some exciting new technologies about the products that has been introduced here. So I'm Nadeem Mirza. I'm a product manager for backflows here at Watts. And today we'll be taking a new and exciting look at how the world around is changing. And as Sandra said earlier, we will leave time for Q&A at the end of the session. So while I'm here, I'm also supported by Pete Battagna, who is our senior engineer. So the questions relating to backflow or anything else that you may have, we'll be more than happy to answer those questions at the end of the show. So let's take this show on the road. So what we'll be talking about today is the pressure vacuum breakers. I think most of you probably already are familiar with that. I will just touch bases on what it is and what it does and why there's a risk to vacuum breakers. Also give you a little bit understanding of double check backflow preventers that they play in a similar space or starting to play more and more in the similar space as pressure vacuum breakers do. We'll talk about the advantages and the value propositions of PVBs versus DCs. And most importantly, as you could see, the freeze commit, that what's the impact of freeze on these PVBs and DCs? What happens with the freeze coming based on what territory that you are in? Also, we'll talk about the freeze sensors that are now integral part of our PVBs and DCs, and we will examine the PVBs, its application, how the whole systems come together with the freeze protection. Also, we'll talk about detail on connecting the freeze sensors as well as the digital converters that are available, as well as touch bases on irrigation management systems. So that will be the synopsis of what we will be talking about. I will try to stop at 2:45 my time, leaving about 15 minutes for us to ask questions that you may have. So just a little bit about Watts. We have been in business for 140 years. I think we are probably the oldest company. We started as a backflow company. We have obviously expanded into other technologies that touch the water. We are America-based company. 65% of our revenues are from United States and Canada. Uh, we also have the huge install base, and we do manufacture most of our backflows here in United States. The two major factories being in Franklin, New Hampshire, and one in Woodland, California. And I'd like to extend invitation to all the Irrigation Association member to let us know if you'd like to visit us, and we'll be more than happy to arrange the visit. We have about 5,000 employees, presence in Europe, Asia Pacific. A lot of our business is in repair and retrofit. Since we have a huge installed base of backflows out there, we are able to do that. Also on the, we play in the commercial side, the industrial, residential, as well as the multifamily homes, as well as non-residential. So that was just a little bit introduction about Watts. Now under Watts, we have multiple brands. You may have heard of Watts as a brand. You may have heard of Pepco as a brand. You probably have heard about Ames as a brand also. So all those different brands that play in the different markets are basically Watts brands. We build them in different factories. They have different application. So they're that's how they're separated by different brands. As I said earlier, most of our manufacturing is done in New Hampshire in United States. We actually have our own foundry in New Hampshire where we actually melt the metal to make the backflows right here in the United States. Similarly, in California, which mostly makes the Ames brand going into fire application, they're all manufactured within the United States. So that's a big differentiation for us, and we are proud to be able to manufacture these products in the United States. So on the irrigation application, that's what we will be talking about today. Starting with the residential application, you can see the sprinkler systems out there that mostly will require PVBs, a 3/4 inch PVB for that application, or maybe if you have a bigger house, maybe a 1 inch. On the commercial applications, irrigation systems, as well as golf and recreation. In a residential application, it will typically consist of single family homes, multifamily apartments, as well as the condo building. What we call commercials will include the hotels, convention centers, and office building. In the irrigation application, you can have drip irrigation, sprinkler irrigation, center pivot irrigation system. So any kind of system that's out there irrigating the green lawns, that's the market that we touch. That is the market where PVB is required, and that is the market more and more double checks being required into that space. So here's just a small introduction to the PVB. And just to go a little bit on a tangent, the question obviously is that, hey, why are you even using a pressure vacuum breaker? And the reason for that is that we have started putting so many chemicals in our lawn, from the fertilizers to pesticide, and not to mention our dogs, which are walking around there, and then we start watering the lawn. There's a risk that all that water after rain, before rain, could get sucked in or back siphoned through the holes that you may have and go into the municipality supply, thus contaminating all of supply for you as well as for your neighbors. One of the reasons we ask that you install it about 12 inches above the highest point of the downstream water. It will have occasional water discharge. It requires a continuous pressure. This is a totally testable device. It has a vertical installation. And by testable, we means that depending on where you are, the code requires that a certified tester comes in and test this PVB every year, just making sure that it's performing the function as it is. and it will help prevent any back siphonage coming into your facility. So other type of the, the protection that's being required is a double check. It prevents a reverse flow of polluted water from entering into your water supply. The same thing that PVB is designed to do. The requirement for DC is to drip tight with a one-piece PSI differential pressure in the direction of flow. These assembly consists of two independently acting check valves, internally force loaded to normally closed position, two tightly closing shut-off valves. And these are designed to prevent basically the backflow of water. It's as simple as that. So the difference between the PVB and the double check is very basic. That one is preventing back siphonage, whereas in double checks, there are two checks, not one, inside the double check backflow assemblies, so that for whatever reason the first check is failing, there's a debris in the first check, or there's some other issues with the first check, uh, uh, that the second check will prevent the flow of the water. And the check, as you or probably already know, is just a check. It has a piece of disc that sits on a seat, and it has a spring that's holding it against the pressure. When the pressure is applied, the disc opens and let the flow go in one direction. But as the flow starts to decrease, or the flow from the outlet starts to increase more than the inlet pressure, the check under the spring pressure will close and shuts off the water movement. So this is in synopsis what it is. All PVBs as well as double checks, they need to be approved by USC and ASSC. That's a requirement. Now, as you know, USC has a pretty stringent requirement for approving these products. It's a minimum 2 years process. Yes, you heard that right. It's a minimum 2 years process for the testing of the backflows, and that process requires 6 months of lab testing. So we will provide USC, which is an independent lab, is part of University of California systems, uh, and uh, uh, and and they will test the unit for 6 months in the lab, and they'll observe it. After the 6 months are complete and they have passed the internal tests, they will be installed in the field. So they will be out there in the field, and somebody from USC will go there and inspect them periodically, typically once or twice per month. So that's a pretty stringent requirement. Now, for whatever reasons you are into the process, 8 or 10 months into it, and they find that this backflow is not working as it is supposed to be working, basically we go back to the drawing board. We look at what it is. We try to fix the issues. We do the testing in-house, and then we send that back to the USC, and the process starts all over again. And the ASSC certification is also part of it. The lab testing that the USC does, that also applies for the ASSC as an agency, who will give us a stamp of approval. Many of these backflows, not these particular ones, but there are other, they may have UL as well as FM requirement also, especially the backflows that are being used in a fire application. They will typically will have the UL and FM approvals on that. These particular one can be installed vertically or horizontal flow up installation in the field. One of the common points between both PVBs as well as this is that they are either installed outside, outdoors, or they will be close enough to the outer wall where if their freezing temperatures are, that may impact them again. That's why we're talking about these particular devices. If there was more, the larger backflows which are installed indoors, uh, this freeze impact will be minimum on them. So why the freeze detection? So those of you who are attending are from, let's say, New England or from the region of United States or Canada, where the freeze happened. We know the freeze is happening. Uh, so we basically take care of fixing that freeze by draining the water, by shutting off and cleaning the water supplies, so there's no water left. Now, the funny story about the water is that in laws of physics, most liquids have a quite simple behavior when they're cooled. So when they are cooled, they will shrink. That means they'll become smaller than they were before. And when you heat them, they expand. That's not the case for water. Water after freeze actually will start to expand, not shrink. So those of us who have left a bottle of beer in the freezer overnight under this phenomena very well, especially when that was explained to you by your wife next morning. So that's the important point to remember, is that why we really do not want to leave things overnight in the freezers that we don't want to break. So the challenge for us is that by nature of the applications, these backflow preventers are either installed outdoors or close to the outside walls. That leaves them at risk if the freeze sets in and devices are not winterized. And that's the important point, is when they are not winterized. And I'll talk about in a second that why they may not be winterized. So in New England, we do that. But in other places like, let's say, Texas, that doesn't always happen. And the reason it doesn't happen is because they don't get a freeze every year like we do in New England. So Texas, the freeze may come in once every 2 or 3 years. And because nobody's thinking about the PVB or the backflow being installed outside, they have not taken care of the water. There has been times uh, I remember quite vividly, even this year, somebody told me that in Colorado area they were watering their lawns even in October. So when that get into that kind of a weather, and I'm sure in Texas they probably watering lawns right now because the temperatures are pretty much into 80 and 90. And when this freeze sets in, they are not thinking about this challenge. So when the freeze happens, a lot of bad things happen at this. There are many things that will go wrong due to that. The body or the housing of the PVBs, main housing typically made of brass or another durable material, can crack or rupture. And this has a impact. Obviously, it has damaged the PVB itself, but when the crack has happened, the water will start. Will nothing will happen as long as the freeze is there. But once the freeze is gone, that crack will start to spill water, and we know what potable water is a expensive commodity, and we need to take care of that. And that cannot be fixed. Either somebody goes in and finds out where the shut-off valve is and shut the water off on the main, and that's if you find out because you're inside, sitting somewhere by the fire, while the water is spilling, and it will be the next day or the day after when your lawn is really watered down, that you will find out. So it has a two impacts on that. The second one is the valve mechanism. This is probably the most critical one. If water freezes inside the valve or around its moving parts, it can cause the valve to become stuck or malfunction. So the space between the ball valve and the body itself is pretty tight. And as the water is expanding, it will break and it will damage that ball valve and the surface around that, which means it will start to leak. The third major one will be silicon discs and O-rings. These seals can become brittle or damaged, leading to leaks or improper sealing. Also, the internal components, spring, the check valves, they will all be impacted. To make a long story short, you got your work cut out for you. So when this happens, you go around looking for the parts or looking for a replacement, and most importantly, looking for a plumber. And what you'll find is that all of the above will be in short supply just when you need it, and Murphy law will take place, and it will do what it's supposed to do. So with that, I want to share a small video with you. Okay, with that, so this is an interesting video, and the reason I wanted to share that with you is that it explains the concept of winterizing in a very simple and straightforward way. By the way, all these videos, as well as information that I'm sharing with you, is available at watts.com. You can look up the instructions as well as the video as many times as you like, and hopefully it'll help you prevent for the freeze next time that you're around. So coming back to the DC, the challenge is the same. Your check valves, DCs are a little bit more expensive than the PVBs. So when they get damaged, it's a little bit more involved to change them, to change the check valves or change the silicon O-rings that may be exposed and uh, be damaged from that. Also, all the internal components. So when the freeze happened, basically what we recommend is, hey, you inspect the whole valve all the way through and just make sure that everything is intact. We also have kits available. Either it's our product or anyone's product. The kits are available that will help you uh, bring the uh, uh, bring the product up to speed. One thing I do want to mention here is that when you're replacing the kits with the kits, the checks, or anything, please make sure that the kits that you're using are the certified kits. Lately, we have seen some Chinese manufacturer come in and selling the products on Amazon. Those products are not certified by USC and ASSE. Remember, there's a local code. The local code says adherence to certain codes, as well as that certain testing procedures are performed. So when one is using a kit that is not certified, that is not recommended by the manufacturer, you're basically risking um, uh, the backflow to not do its job properly. Um, uh, don't just look at the price. Please just make sure that whoever the manufacturer is has approved it. It has approved USC. Ask that question: is that product approved by USC? Ask the question: is that ASSC? Check at your local codes. So if you are not going to be using an approved seal, basically that PVB is out of code. And if something happens with that, there are liability issues associated with that. So this is something I speak from experience. So please do look that up. Just don't go for the best price at Amazon. There's a little bit more to it. Remember, the only reason you have a backflow preventer or PVB in the field is to prevent the risk of backflow. If this is not going to do that job, then it's just another valve sitting out there and not performing the functions that it is supposed to. So in current situation, what we recommend is use the insulation or enclosure. That's a very simple one. You can put that on top of the backflow and hopefully it has enough insulation in the enclosure to do that. Drain and shut off the valve, take out all the water or as much water as possible from there. Heat tape is another solution. I use that right here in New England. I have a pipe, a water supply running with the wall in my basement, and it's out of sight, so it has a risk of freezing. So I'll just take the tape, heat tape, uh, wind it around that pipe, and it keeps me safe in winter. Do the professional inspection. Have your lawn care guy come in, have him take a look, if possible, winterize it, just to make sure that it doesn't give you any problem. Now, let me jump into this new technology. This freeze sensor is designed basically to look at the temperature around the backflow. Now, it's not looking at the water supply temperature. It's actually looking at the ambient temperature. So let me be clear about that because there's some misconception that we should be looking at the water. And the reason we don't want to look at the water is that once the water starts to freeze, it's already too late. With this, what we are trying to do is somewhat predict that based on the ambient temperature, what the temperature is right now, that you are at risk or your PVB is at risk for freeze. And if it at risk of freezing, you should be doing something about this right now. With the certain model number that I mentioned earlier, the PVB 800, PVB 765, those are the number one sellers in United States, as well as the 007s and 850s typically used, a double check typically used on the entrance on the main. They will have a freeze sensors installed already on them. So look for the tag that you see here on the screen, and they will come as a standard part of these particular backflows. And the good news is that there is no cost to it. We are looking at preventing the damage to your product. So this is the first step in doing that. And I'll talk a little bit more about it, that how do you connect these sensors and how do you get the information from them. So once you have the full system, it's designed to do three things. One is it will monitor your backflow preventer 24/7. You will have the ability to get real-time alerts when the freeze conditions are detected, or when it's getting close to that freeze condition. It'll hopefully prevent the freeze damage. So you once you get an alert and it's annoying getting text messages or Wi-Fi messages, uh, it will make you take action. That's what the hope is. And rather than replacing a cracked backflow, which is costly and time consuming, that it does not happen. And the last point that I made earlier is reduce water waste. It minimizes property damage from the water that may be coming out of the cracks that you don't see just because it's outside, out of reach. Until you do a visual inspection, you won't see what that crack and the water coming out could potentially do for your property. So those are the three key features that I just talked about. And the last one is integration. So how does this all come together? So in a Sentry Alert Plus technology, Sentry Plus Alert, by the way, is a technology from Watts. And we use the same technology in different places. If you would have seen some of our RPs, backflows going out, they already have flood sensors built into it. So when RP malfunctions and there's too much discharge, Sentry Plus Alert technology helps detect that and provides alert either through the cellular gateway or through your Wi-Fi or building management system. But in a case of freeze, what our system will do for you is that through use of our kit, technology kit, uh, it will let you integrate that into a irrigation management controller that you may have. We have tested that with several different manufacturers' product out there. You just need to make sure that the unit that you're using, number one, has an input for the temperature sensors. Is pretty standard for many units, not for others. And number two, if you want to get alerts, make sure the controller that you're using has a built-in Wi-Fi capabilities to be able to send you those alerts. This is a phase one for us. We are releasing these product line as we speak. As we move forward in the future, and future I mean early next year in January, you will be able to have the same kits with the Wi-Fi connectivity already built into it. So you will be able to connect these kits either to the local irrigation management system, which could also be controlling your sprinkler system, as well as send you a Wi-Fi alert independent of what kind of a controller that you may have. So again, at this time, there's a little bit of limitation that the controller that you have has to have, number one, input for the freeze sensors, and number two, capability of sending you alert. So what makes it so smart? Why is those different? Why can't I put a temperature sensor out there and start to continue to get alerts? And there are two reasons. The temperature sensors out there, they just sense temperature. When the temperature goes down, it's going down, it reads the temperature and it says it's 32 degrees outside. So it's 32 degrees outside. But when we come to alerts, being able to send you alerts, uh, there's little bit more to that. So the idea behind that is we do not want to send you alert just because the temperature dipped down below 37 or 32. What the smart controller is doing is that converter is doing is it's actually continuously looking at the outside temperature, and only when the temperatures stay below a certain point for a long period of time will it get alerts. So there's an option of doing a 60-minute delay or 30 minutes delay, but the delay has to be there. So in translation, what that means is that on a 37 degrees temperature, if it dips down to 36, 35, and it's only there for a few minutes for whatever the reason it may be, and it goes back up. The timer resets itself, and then starts the counter again. So we just want to make sure that condition is existing and it's persistent for us to be able to send an alert. And then there are two types of alert. There are two type of connections coming out, and you have an option of whichever connection that you would like to use to your controller. The first option we call a pre-alert. This is an alert that's set at 37 degrees F, so it's well above freezing point. Right, so it's giving you an alert, giving you an indication, saying, "Hey, something bad is about to happen. I've seen the 37 degrees temperature and stayed there for 60 minutes." So you can take an action on that, and you says, "Nah, 37 degrees. It's going to be warm tomorrow, and I'm back to whatever I was doing." And then the second type of alert, if you want to make a connection with that, which is at 32 degrees F. So now you have reached a freezing point, and it'll send you the alert if it senses that that alert is for 30 minutes only. And this is a time for you to really take action, to do something about that. If you want to cover it, go ahead and cover it. If you want to drain it, please drain it. This is a time. Uh, these will not start freezing right away. And that's the whole idea of giving you an alert. Those temperature will need to stay about 24, 25 hours, depending on the size and depending on the location of your backflow, that it will start to freeze and expand. So you don't have to. You have basically this alert is your 24-hour notice to do something, and if you don't do anything, and the alert and the temperature say below freezing, you will have an issue. So if you look at on the right hand side, the way this whole thing connects is that you have a sensor mounted on the backflow. You can see the tag. I don't know if you can see my, you probably can't see my cursor. Oh yeah, here it is. So here is the sensor that you see, and it will come with a tag to identify that, hey, I have a sensor built into it. With the wire, you will connect that temperature sensor to the smart converter. It has an input for that. And this smart converter will require a power. We recommend that you install the smart converter control close to the controller. In some places, I've seen that installed in the garage. In other places, the controllers are installed in the basement, depending on what part of the country you are. Everything else is being done inside the converter. As long as it has power, it's constantly looking at the temperature and it's looking at the time, and it's going to be making decision for yourself. If you feel like disconnecting that in summer, you don't need it, go ahead and do it. But then do remember to plug it back in. If it's not plugged back in, it will not be doing anything. So the magic happens right here in the smart converter. It has done all the calculation, and it has provided an input to the controller, irrigation management system controller. Either it's that in your house, it's in a commercial building, or wherever it is. And from there, the controller will take over. If it has a Wi-Fi, it'll send a signal out uh, uh, to whoever you have programmed that signal to go out. Either it's a homeowner, a building owner, or if you're a landscaper yourself, to yourself. So the idea for the landscaper would be that if you're taking care of somebody's lawns, that this is an opportunity to give them a warning saying, hey, something, we expect the freeze to be coming in. And if you can go about and make the change and winterize the stuff, that will go a long way to helping a homeowner or building owner that you're thinking about him or her getting in an issue with their backflows. when you're looking at what controllers is connect to, look again, this is an important one. Look at that it has a relay input for the temperature. And number two, that they have the Wi-Fi capability if you want to get the alerts. If you don't want to get the alerts, you don't need that. Again, as I said earlier, the next release of our smart converter coming up in January timeframe, it will have the Wi-Fi capabilities built in. So just for the alert application, you will not need the controllers for that purpose. Now, with that, we are close to our time. The three things that is going to be offering is peace of mind, 24/7 monitoring, detecting potential freeze condition. It'll provide the real-time alerts. It saves you time and stress of dealing with disastrous freeze, and not to mention what the cost may be. Talking about cost, PVB typically will cost $150. Double check twice as much. So they are $300-400 right there for you. And if you have a plumber coming in emergency, that's be a couple of $100 also. So from that, this is a really great investment that will save you, that will work for you many years going into the future. So in summary, and I know it's 45 minutes is a very small time to cover such a large subject. Uh, we have a basic understanding of PVBs. We talked a little bit about the DCs and how they work and their application, and become familiar with the application as far as connectivity to the building management systems, as well as the irrigation management system is concerned. So with that, I will open this up for question. Sandra will be moderating the questions for us, and we will try our best to answer your questions. If we can, please feel free to visit us at our booth at San Antonio, number 342, and we will have some people live for you to be able to answer any questions. Thank you.
Thank you, Nadeem. We do have a couple of questions in the Q&A box, and the first one is, are alerts available through non-Wi-Fi communication methods, such as cellular communication or hardwire Ethernet?
Right. So a good question. The question is, are the alerts available other than the Wi-Fi controller? At this time, the only alerts that are available are are through the irrigation management controllers Wi-Fi capabilities. In future, those in January, as I said, when we introduce the Wi-Fi, that will be able to provide you over the internet. At this time, we don't have plans of introducing cellular over the cellular gateway. And the only reason we think about that becomes a little bit more expensive solution. When you're using the cellular waves, there's a cost to it, just the same way as you carry a cell phone. We do have cellular option for our flood sensor offerings. So if you have a flood sensor offering, some of our products are coming standard with those flood sensor offering. You can purchase the cellular gateway that works with our system. It's not very expensive, and for the first 2 years, the service would be free. So yeah, for the irrigation side, we don't have it at this time, but once I talk to some of you folks at the booth 342, we will definitely put that on one thing to do.
Thank you. The next question is, for customers who always winterize before the freeze comes, what is the need for this product?
Okay, good question. So if you're already winterizing, and my emphasis is prevention. So I live in New England. So in New England, we winterize. So you will see a very little benefit from this product as itself, because you have already taken care of things. I think the most of the application, and you'll be surprised that most of our PVBs and are actually sold in the markets where we don't have I would say, winter or freezing weather every year. So to answer your question in summary, um, the value proposition where you're already winterizing, where you're already taking care of it, where you're already changing the oil, is very small. But for those folks like us who forget to change oil in their car, that indicator light that shows up and says, hey, time to change oil is very, very beneficial.
Thank you. Next question is, can I power the smart controller from the irrigation controller?
Uh, it depends from controller to controller. The easiest way is that this smart controller already comes with a power supply. So the power supply is there. You can probably do that, look inside the controller and run the connection, 120 volt connection to this. The easiest thing is you already have a power supply. You already have, I'm sure, a plug nearby. Just plug it in and it will do what it's supposed to do.
I think there's a second part to this question, and it says, is it basically a freeze switch?
It's a little bit more than that, right? Because the switch will just react. When it senses a temperature, it senses a temperature, it'll open or close. That's kind of a switch that some of us who has worked with the cars with the radiators would typically have. When the temperature gets too hot, it just switches on and off. This is a smart one, right? If I remember when I was talking about that, it's looking at the temperature, what the temperature is, and at a given temperature, then it's starting its clock. It's starting its time, and those are two different temperature side. So yes, the difference between would be in a mechanical freeze switch. That's what it'll do. Here, it will provide a little bit more brains, a little bit more smartness about the changes in temperature.
Thank you. We have another question here. For larger systems, are the freeze sensor available on RP backflow prevention devices?
Excellent question. So the question being asked is, hey, Dad, do I need for the larger units also? Absolutely. You can buy the kits right now. If you look at one of the pictures before, it has a small sensor that comes with the kit itself. So you can take that, and because I'm measuring the ambient temperature, you can put it on the test cock. So right now we have this available for this with a 1/4 inch or 1 inch, 1/2 inch test cock. Yeah. So right now it's 1.25 to 2, but definitely we have plans to introduce for the larger sizes and eventually for the other sizes. So that's an excellent question. Reason that, let me give you a little bit of background from that. Hey, how did we come up with that? The smaller the physical size of the unit is, of the backflow is, earlier it will freeze. So the smaller one are more at risk than the larger ones. But last time we had freeze in Texas, I've seen 4 to 6 inches freeze open. That's very, very real. We also see an opportunity. We also see an opportunity on the work sites. Even in future, you may want to place um, the backflow indoors, but if once a building is being built and you have a backflow sitting outside, you want to make sure, and especially if the water is not moving in that backflow, you want to make sure that this is not going to freeze. Also, the same technology you can actually use on the tube. So if you look at the clip, the way it's made, I think it has a inner diameter of about ½ inch, and you can just it doesn't need any screws. It just clamps around that ½ inch tube, and there will be one available for larger sizes also. And you could actually prevent the tubes that may be running in the rises, that may be open to the space, especially in the winter. So it has a very broad application of the same technology. And as we move forward, there's more and more will be coming from Watts to help prevent those breaks.
Thank you. We don't have any other questions. There was a suggestion to inspect the interior components, springs, seals, gaskets, interior, etc., prior to preparing for winterizing the backflow preventers and prior to introducing pressurized air. They're normally tested once annually. May have to replace components. So this wasn't really a question, it was a suggestion that was in the Q&A box.
Right, and an excellent suggestion. I always recommend that, and people blame me for trying to get more sales, but it's always prevention is always better than cure. If you can inspect it when the inspector comes in and he can look at that and see there's something not looking right, change it. Change it may cost you 20-30 bucks for that change, but it will prevent hundreds of dollars in damages in the long run.
Thank you. So if anyone else has any questions, please type it in and we'll do our best to answer it. We do have a few minutes left. While we're waiting for people to type in their questions, are there any other last thoughts you would like to share with the audience?
Yeah, absolutely. Well, first of all, thank you for being part of this conversation. And I know this is a little bit different than totally when we talk about the backflow, and I'm 200% sure most of you have already dealt with this thing, with the backflows as you move forward. At Watts, we are trying to bring the backflow as self as a technology into the world of today. And our effort to bring smart and connected technologies to every aspect of a backflow is critical. And the main reason for that is that this is the backflow is the only reason is for safety. And if we can help improve the safety, our job is done. That's what we are in business for, to keep you safe and keep our environment safe.
Thank you. That was a great comment. It doesn't look like we have any other questions in the Q&A box, so we can wrap up. If anyone does think of a question after the webinar concludes, please send it to education@irrigation.org and we'll make sure that the appropriate presenter or anyone from Watts receives the question. So with that, I will thank everyone for attending today's webinar. And please don't forget to check the Irrigation Association's website for upcoming webinars throughout the year. Thank you to Nadine for sharing your knowledge with us today. And thank you to Watts for sponsoring the webinar. Have a great day, everyone. And this concludes the webinar. Thank you.